Sometimes for the sake of the length of the video, I might not finish the problem. I might just set it up because that's the new part for us. That, like in the last video, I ended the example without solving it, but you should be able to knock that integral out since it's fairly basic. Okay, I don't want to make these videos too long. The new part and the key is the setup. So let's try this one. Now here's the new part. The axis of revolution is not the x-axis, but it's still a horizontal line, right? The x-axis is a horizontal line. All right, the x-axis is the horizontal line y equals 0. But now we're going to switch it up and say y equals 1. Okay? So we're going to have to think of, it's the same process. We're just going to have to think about what big R and little r is. Same formula, same process. All right, the y-axis is x equals 0, and we'll get to that a little bit later. Okay, x squared plus 3. 1, 2, 3, parabola opens up. Something like that. Y equals 3. That's right here. X equals 2. Now, let's scale this to there so we have a nice some space to work with here, okay? So this is the region. Now, if we're rotating around the x-axis, then r would be the distance from here to here, and little r would be the distance from here to here, right? Okay, but we're not doing that. We are rotating around a different line. That's this line. Oh, so now we get to think about this. This is a good one. What is the distance? Here's big R. It's the same idea. You just got to think a little more. That's big R, function of x. And then what's little r? Well, you could draw it pretty easily, right? It's from here to here. That's little r. Okay. So, what do we think about that one? What is big R? Okay, so let's just say this distance was, you could do the math. At x equals 1, so at x equals 1 squared plus 3, you get 4. Right? That is, the distance from here to here is 4. So what's the distance from here, the red line, from here to here? Well, that would just be 3, right? You would subtract this distance. That's all it is. So big R is my function value, which is giving me anything on the line or anything on the graph, any output on the graph. So it's the function value, x squared plus 3 minus 1. And then little r, it works the same way. Oh, this one is pretty straightforward. Little r, you can see, is distance of 2. But it's this line, the function value, take away 1. So if this weren't a straight line, it would work the same way as big R. You would just take away that distance here. Okay? So I have the volume, and as you can see, I'm not even bothering to draw this figure because it would be like this, and then there'd be a big hole in it. So you'd have like this region, and then a big hole, and then you do that everywhere. And then down here, it looks like that. And you can see why I'm not attempting, because this is a really bad drawing. But the hole in the washer method should be constant. It shouldn't be like changing, but this part would change. So this is kind of like, I don't know what it's not terrible, but it's not good either. But anyway, you don't have to draw those. They're kind of fun to attempt to draw. I'm not very good at it, as you can see, but we trust in the math, and the math goes like this. X is going from 0 to where? Well, it tells us, so that's good. There's no intersection point, so it goes from 0 to 2. And I got pi, and I got big R, quantity squared, which is x squared plus 2. And then I got little r, quantity squared, which is 2 squared in this case. All right, should we do this? Let's finish this one off. So I got to do some algebra first. 0 to 2. This is x to the 4th plus 4x squared plus 4 minus 4. Oh, that's convenient. That goes away. And then I have pi from 0 to 2, x to the 4th plus 4x squared dx, and I integrate, I get x to the 5th over 5 plus 4x cubed over 3, integrated from 0 to 2 times pi, and hopefully I didn't make any errors. I'll check my work here in a second. That's 32/5 plus 8 times 4, 32/3. And then 0 would go away in this case. And if I'd probably go to my calculator at this point, or you can do, we like exact values as well. If I go to my calculator, I should get, or that should be 256 over 15 pi if you find a common denominator of 15.